Let's continue our deep dive into the dimensions of data quality. The fifth dimension is currency. Currency is measured by these two characteristics. The first is data timeliness. Data timeliness measures the delay between when data is available in the system versus when the data is available for consumption. For example, in sport, a player will win a point, but the official score may not be updated for a few seconds or even minutes. A short delay may not be an issue, but for a longer delay, hours or days, might cause issues when trying to process the data. The second characteristic is data freshness. Data freshness is a measure of how up-to-date data is to the real-world event that created it. Using the example above, someone again will see the updated score when the player wins that point, but until the score is official, i.e. reflected on the score changing on the scoreboard, everyone is still seeing the old score. Similarly, if the real-world object changes and there is a delay between the change and when we can see the change in our data, this may also impact data processing. In summary, for data to be useful, it must be kept up to date. Otherwise, you risk making wrong decisions. Equally, whenever the real-world object changes, it's important that the change is recorded and made available as soon as possible, as any delays could likewise allow for incorrect decisions to be made. The sixth dimension is reliability and credibility, and this is measured by the following three characteristics. The first is source quality. This is a measurement of how reliable the source of the data is. For example, if the data relates to a customer, did it come directly from the customer or via someone else? If the data has come from an external source, then how reliable is that source? Another example is the use of a family member to act as a language interpreter. Do we trust that the messages will be communicated as required, or would the use of an independent interpreter service yield a more reliable result? The second characteristic is objectivity. For data to be useful, it must closely model its real-world object. This means that data is recorded based on observations, not opinions or interpretations. In other words, this characteristic measures the degree to which data is recorded free of any bias. The third characteristic is traceability. This characteristic measures the degree to which data is traceable back to its source. For example, can metadata be easily found for each data item? In summary, data that can be traced to or verified by a reliable source is likely to be of higher quality. To ensure this traceability is possible, data must be recorded free of any opinion or interpretation. The seventh dimension is usability and interpretability. These can be measured by the following five characteristics. The first is usefulness and relevance. This characteristic measures the degree to which data is useful to the business for the purpose it was collected for. For example, if the customer email address is not mandatory, then it may not be useful for sending promotional material if there are gaps or blanks or nulls in the email addresses. The second characteristic is understandability. Is the data stored in such a way that it is understandable? For example, it is common practice to store coded values to represent common descriptions to minimize storage space. If we store the code without a way to discover the meaning, then the data consumer may have to perform additional tasks to interpret the data, possibly leading to inconsistencies. The third characteristic is appropriate presentation. Data must be stored in such a way that it represents its metadata. This is also important for when the data is presented. This characteristic measures the degree to which presented data matches any defined metadata. For example, if we collect and store the date and time of sales as date/month/year, hours, minutes, seconds, but on a report we just show the date part, not the time, then we may not be representing the data appropriately. The fourth characteristic is interpretability. This characteristic measures the degree to which data can be easily and consistently interpreted. For example, if a value can be one of 1, 2, 3, meaning low, medium, or high, then the latter description would be preferable, or using a standardized code set which allows for the retrieval of a description. The fifth characteristic is information value. The fifth characteristic is information value. This measures how valuable the data is to the organization. This may be a ranking, 1, 3, 5 being low, medium, high, or it could be a dollar value. In summary, data must have some intrinsic importance to the organization to warrant its collection. To be valuable, we must be able to interpret it and understand it. Part of being able to interpret data is having it presented in a way that we would expect to see it. The eighth and final dimension is validity. This can be measured by the following four characteristics. The first is business rule compliance. While characteristics such as format and uniqueness can be linked with business rules, there may be additional rules such as a value must be part of a predefined set of acceptable values, a value may or may not be blank, or the value must be greater than or less than another value. This characteristic, then, is a measurement of how well the data matches these defined business rules. The second characteristic is metadata compliance. This characteristic measures how closely stored data matches the metadata. For example, if the metadata states that an attribute is unique, then is it stored in such a way that duplicate records cannot be created? The third characteristic is standards and regulatory compliance. Data may be related to or defined by regulations and legislation. This characteristic measures the degree to which data aligns with any relevant regulations. The fourth characteristic is statistical validity. Statistical validity refers to whether a statistical study is able to draw conclusions in agreement with statistical and scientific laws. This means if a conclusion is drawn from data after experimentation, it is said to be scientifically valid if the conclusion drawn from the experiment is scientific and relies on mathematical and statistical laws. In summary, data is considered valid if it conforms to its definition, i.e. metadata, and business rules, including any regulatory standards or laws. Data may also be considered valid if it can be confirmed using statistical analysis. That's the end of Module 2. In this module, we have taken a deeper look at the 8 dimensions of data quality and looked at the 33 individual characteristics that help define and measure each dimension.